So guys, we will be going through this course content where we will be learning first of all Docker, what Docker exactly is, how to create container, how to create Docker images by writing Docker file, what Docker swarm is, see here some differences between LXC container and containerd, and we will be learning how to do installation, a basic installation to Docker engine, and we will be learning Docker architecture, how Docker exactly it is working. We will be seeing networking services and what Docker registries, underlying technology. What is this? Okay, sorry. Underlying technology of Docker namespace and PID and all, how it works, right? How a Docker container is working, what all processes are running inside it, how Docker containers are getting resources, your RAM and CPU, right? And we will be comparing virtualization versus containerization, both the things. Image and container management, like how to create images, pull it, and what all image layers are, right? All those things we'll be seeing, and we will be learning about Docker networking, understanding network IP, and somehow what all class IP classes it is using, what we are communicating, how we are communicating with our container. Okay, all those things we will be seeing here, and Docker storage, what all type of storage we are having in Docker containers to make it permanent our data. Whenever we are starting a Docker container without a volume, what happens to them, right? We will be learning that thing. Okay, if we are starting our container, give me a second. Now can you hear me there? All about containerization, once image is ready, how we can first of all how to create images. Once your image is ready, we can how we can create container, and how we can convert a running container to image. All those things we'll be learning here. Okay, registry management, like we will be having Docker registry, how we can host our image to Docker hub, and how we can convert our existing GitHub account to Docker registry. Some local registry option is there that we can store our containers. We can store our image in Docker container as well, that we'll be learning. Secure communication, and Docker compose, Docker machine, Docker swarm. Docker swarm is what Docker machine is like. Docker machine is a computer or is a server. Like you can manage multiple remote servers from that particular server. Even you can install Docker remotely on the remote servers. We will be learning about Docker machine, and Docker Swarm is an orchestration tool provided by Docker. How we can create replicas of our application. How we can create Docker Swarm cluster. All those things we'll be learning here. Okay, these are some tasks we will be learning. Automated, like how we can automated tasks to create image by using Jenkins. Okay, we will be learning custom Docker file, writing custom Docker file. It's not like that. Node.js, and some of the example we'll be seeing here. Deploying WordPress database for storing storage using Docker Compose. Okay, Docker Compose. How we can start? No, the use of Docker Compose is like if you are creating multiple container by running Docker and command, and by using a lot of configurations in it. That is not a good idea. So we'll be writing all the configuration in one file, and we'll be starting our containers by using Docker Compose. Deploy of application using Nginx, MariaDB, and Jenkins. Yeah, we will be seeing some examples of it. What JSON is, what YAML code is. Before starting Kubernetes, we need to learn, JSON and YAML. YAML is like, very required to learn or to write Kubernetes deployment. I will giving you some shortcut so that you can generate YAML code. But we should aware of YAML, how to write YAML code. Okay, so if we are facing after generating your YAML code in Kubernetes, if we are facing any trouble or any error, so we can troubleshoot it. If we are having a knowledge of YAML, we can easily troubleshoot it. If we don't have knowledge of YAML, it is a problem. Okay. Kubernetes architecture, what all components we are having in Kubernetes that we will be learning here. Okay. Kube API server, controller manager, scheduler, core DNS, etcd, kubelet, kube proxy, how Docker engine is helping us in Kubernetes, what is the role of the Docker in Kubernetes, right? These all things we'll be learning. What all components we will be having in our worker nodes, compute node it is written. We'll be seeing all those things. Okay. Deployment of Kubernetes using micro-K8s, Ubuntu, Cube, Minikube, and KubeADM. Okay, so we will be doing here is we will be creating our cluster using KubeADM tool. We will not be using Minikube because this is just for developers, and we cannot use full feature or full functionality of Kubernetes in Minikube. So we will be installing Kubernetes on our virtual machine. Let me tell you how we'll be installing it. We will be having Oracle Virtualbox like this here, and I will be creating cluster in this 3 machine for an example. Let me leave somewhere. I'm having one cluster ready with it or not. Okay, like this, see here. One master and two worker node we will be having. We will be seeing how to create Kubernetes cluster on Virtualbox, how to enable networking in between all these machines, how to assign IP addresses, okay, and if it is required to see some of the practical on cloud, then we will be learning on AWS cloud. Okay, we will be installing Kubernetes in AWS cloud, and we will be implementing some of the required practicals. Okay, like how to claim volumes dynamically, how we can claim a volume and how we can delete that volume. Those kind of things we will be seeing on AWS cloud using COPS or EKS. Okay. And pod object using container and multi-container. Okay, how to create pod, what exactly pod is nothing but it is very similar to your container, but in Kubernetes pod is a container of containers. We will be creating our containers inside the pod. Replication controller, what is the use of replication controller? Let's say you want to make highly available your containerized environment, containerized application. So how we can create a replica of our application, we will be learning in we will be learning here in replication controller. Then we will be having a replica set. What is the difference between them? Replica set and your replication controller. Replica set will be having set base selector. Okay, this is very good thing, and deployment is the latest terminology of your, it is mix up or it is mix up for your replication controller and replica set. We will be learning that here. Deployment, once we are creating deployment, in future we are getting new releases of our application, how we can do rolling update. If anything goes wrong, how we can revert the changes. Okay, so this is the thing that we will be learning here in deployment. Daemon set, what daemon set is? Let's say we are having some monitoring tool, we want to install monitoring tool. So we will be learning what daemon set is, why daemon set is important in monitoring tool. Whenever we are creating any deployment, so we need to define number of replica, required number of replica in your deployments. But here in daemon set, you no need to define any number of replica. As soon as you are creating daemon set deployment, each nodes, each of the node will be getting one of the replica of your application created in it. Okay, this is a major difference between daemon set and your deployment. So daemon set basically used by a monitoring tool or logging tool. Stateful set, what are the use of stateful set? Like if you're having some database driven application, your application is storing some database, so you want to make it highly available, that database also. So we are having option of stateful set. Stateful set will how to scale in, how to scale out your database pods or containers. Okay, we will be learning here in stateful set how to do rolling update, how we can do rollback here, right? We will be learning in this stateful set. It is very interesting actually. Then volumes, what kind of what different kind of volumes we are having in Kubernetes. So we will be learning like empty directory volume, host path volume, NFS, and different type of volumes we will be learning here. Persistent volume, PVC, persistent volume claim, and storage class. What exactly is we'll be learning a difference between all of these. Okay. Basically, by using storage classes, we can dynamically claim the volumes. Services, how we can access, it is quite easy in Docker container to access your application from outside of the server. It's quite easy. Just do the port mapping, your application will be available, it will be accessible at the time. But here in Kubernetes, you need to create services, then only that application can be accessed outside of the server. So to make it accessible, our service outside of the cluster, we are having different type of service, like cluster IP service. First of all, it is very important, cluster IP service will be making your service accessible within the cluster, not outside. Within the cluster, it will be accessible. What is node port? Node port is nothing but you can access your application outside of the cluster with some port numbers, your server's IP address and the port number. We are having load balancer also, external IP as well. But that load balancer can be used only on cloud. External IP and external name, we can have some domain names mapped to our server by using some load balancer, or by using Nginx load balancer, we can make it accessible our application. Secret and config maps, how to manage password if your application needs some password. So how we can manage secrets from one place, how we can reuse that secret in multiple deployments, we'll be running here. Config map, how we can see, once we are creating Docker file, that is a good idea, we can create Docker file, that's fine. But in Kubernetes, you're working Kubernetes, and some of the settings that you want to change in Docker file, what we'll do, it doesn't look good to just go and recreate the Docker file again and again. That is not a good idea. But config map allows you to override your existing configuration of Docker file by writing config. Quite easy and interesting thing that we will be learning. And Ingress controller we will be seeing. Yeah, Ingress controller is also very interesting thing. Like how we can have multiple application in our server, in our cluster, and how we can map it to particular domain like shop.abc.com, blog.abc.com. How we can do that. HPA, horizontal pod order scaling. This is very good feature that makes Kubernetes very famous and more usable in the market instead of going with Docker Swarm. Auto scaling. Let's say I'm having 3 replicas or 10 replicas running in my environment, in my cluster of my application. 3 replicas running, that's fine. Somehow suddenly some traffic increases on my server to access my application. Now those containers are not enough to serve the traffic. Then we are having Kubernetes feature called HPA that will be allowing, or that will be creating defined number of maximum replica of your application. If you are having 10 replica, you define maximum 20 can be created. So Kubernetes will be creating more replica, like 10 is running, it will create 3 more replica, and it will monitor that these 3, and now we are having 13 replica of our application. Is it good, or is it serving traffic properly or not? If it is thinking like, okay, this 3 is not enough, again it will create more 3 replica. Maximum it can create at 20. Okay, minimum is 10, maximum 20, that we will be defining. So maximum 20 replica will be created. As soon as traffic is going down, Kubernetes will be checking it out. Okay, traffic is it is cool down now, it's time to delete unnecessarily created replica on the server. It will be started deleting those replica again and again, and it will be reaching to number of 10, minimum number of replica, that is 10. This is how we can do horizontal pod order scaling, HPA. Scheduling and probes, we are having scheduling. This is a very important session if you guys are planning to do certified Kubernetes administration certificate. So it will help you a lot. This course content is basically for working in a company, corporate company, and as well as it will help you to achieve your CKA certification. Okay, so scheduling is a separate part, and it is very interesting. Once we are creating a pod, so how that pod is getting created in our cluster, who is creating that pod in your cluster, how to do manual scheduling. Okay, we are having scheduler. That scheduler will be, it will be going and it will be checking it out in which node resources are available, required resources are available, and wherever it is finding the resource, it will be marking that node and it will be informing to kubelet to create one replica of your pod there. Okay, how we can manually schedule a pod by our own, how we can select node by our own, how we can select node by using some of the labels called node selector, what pod affinities, what pod anti affinities, how we can define that, go to create pod in this kind of node. Okay, once pod is created, next time you are creating another deployment, so we can say a pod to wherever this kind of pod is deployed, just go and deploy there. So this will be pod affinity. If you are thinking like, okay, wherever this kind of pod is deployed, do not deploy this pod there. Okay, so this is pod anti affinity. Node affinity, where my pod should be deployed in a node. Pod node affinity, anti affinity thing we'll be learning. What is the job and cron job? We can schedule some kind of job and cron job in our Kubernetes cluster. It is very similar to your cron tab. Okay, what is CalicoNet? Okay, what it is? Moved actually. Yeah. What is Calico networking? About Calico and Flannel we'll be learning. Okay, on how this is the section about RBAC, role based access. How we can create multiple user in our cluster and provide them access as per their role. Let's say we are having a team of 5 people in our company, where we can assume that. So my job is to manage the cluster. One of my colleague, he just want to see whether that application is working or not. That's it. He will be running a kubectl get commands. Node is there or not. So I will be giving access to see the resources of cluster. That's it. Another colleague I'm having in my project, so I can give him access to create the deployment. That guy can create the deployment as well as he can see the cluster state, what all things are running, what is not. Like this kind of thing will be falling under rollback. We will be learning here. Kubernetes gives you one graphical user dashboard. By using this graphical user dashboard, we can do the deployment. We can do the deployment there using our CLI dashboard, but most of the time in companies you might not be seeing that, but we will be learning it. Still, we will be learning that one. How to create dashboard. Helm chart. What exactly Helm chart is? Helm chart is nothing but it is a kind of package manager similar to Linux. We are having RPM packages or Debian packages. We can create our deployments packages. So Helm chart will be helping to create package your application, and we can take that package to any of the Kubernetes cluster to do the deployment. How to do setup, what Helm chart is, how to write custom configurations, how to see here custom chart deployment. All those things we will be learning here in Helm chart section. That's it. And somehow we will be learning EFK and Prometheus Grafana deployment using Helm chart. So I hope guys this was the course content. If you are having any question regarding this course content, please ask me.
Yeah, Anish, what does Docker does and what does Kubernetes does?
Yeah, that is the reason I'm going to that part. First of all, I'll have to tell you about course content that we're gonna follow. This was the course content. Now I'm gonna tell you about Docker container and
Just
Kubernetes.
one question. Just
Yeah,
one question.
yeah.
When the course is going to be started? We have been waiting for it for last 3 weeks now.
You are waiting for?
We have been waiting for this course to start for last 3 weeks. When is it going to be started?
It will be starting from, I guess it will be starting from tomorrow, most probably. My team will update you. I think you joined this another demo. This was the second demo that you joined again, right?
Yeah, so I was expecting it would be started last week. It didn't start it last week, so I'm
Huh.
a bit concerned
Asif.
about when it's going to be started.
Yeah, it will be starting. It will be starting. And Asif, you already joined that previous demo. I think 28th August demo, and today is this is another demo. So it will be started soon. I guess tomorrow itself you'll be starting.
Okay, no worries. Thanks.
Okay. So how many of you joined that previous demo? Yeah, guys. Only Asif?
I also joined Naveen. I joined. Yeah.
Okay. Okay. So guys, I will be giving you quick overview of Docker and Kubernetes. What Docker is and what Kubernetes is. How Kubernetes, how Docker and Kubernetes helping us in what all scenarios.
Anish
Okay, guys.
Prasanna here.
Yeah, Prasad.
Containerization we are covering here.
Yeah, definitely. We are covering containerization.
Okay, okay, Anish.
How to containerize your application, what all things are required to containerize your application. Those all things we'll be learning from the scratch. We'll be slowly moving from basic to advanced topics.
Okay, this course will help me to the CK certification, right?
Definitely, that's the reason I just shown you this course content.
Ah,
And even I can help you in that CK also if you need preparation content that I can share. And if not promising it again, if I'm having coupon code that I can share with you, if I'm having this conditional thing, if I'm having
okay.
some offers on CK, because it is like costly examination, right? Let me tell you about this thing. cncf.io, Cloud Native Computing Foundation. Go to certification, go to CK section here, and it will charge you 375 USD. It will cost you
Okay.
375 USD. So if I'm having tokens, so coupons, I will share with you, and I will suggest you, register for this examination during, Christmas and New Year. 50% off you might get. And
Uh-huh.
I think, one token I was having, one coupon, that is for 50% off. But I'm not sure. I'll share with you once we are continuing the session. Just try to register it. So this examination is like once you are registering, once you are paying to them, this will be valid for 1 year. And within 1 year, you can schedule your exam anytime. Okay. One proctor
Okay.
will be with you. He will be very strict. He will be telling you like, show me your room, start your webcam, and what all things you are having on your table. Just show me what is under the table. Can you touch that wall? Can you remove this, that? This kind of question he will be saying you in when it comes to the examination. So 20 question will be there. You need to do 20 question, and those 20 question will be very easy. If you are having understanding about Kubernetes, they will be, it is very easy, and they will allow you to open. This is open book exam. You can open Kubernetes.io website. Kubernetes.io. You can open this link, this website. It's document where this documentation is. Yeah, you can open documentation. If they are giving you some task, it is scenario based exam. Basically, it is not the MCQ kind of like one question is there with four options, choose one. This is not like that. They will be telling you create this kind of deployment with this label. So that's for deployment here. If you don't know, okay, if you don't know deployment code, if some confusion is there, so you can copy this code and create deployment there. Copy paste is allowed there. Okay, but you should be in camera. The proctor will be monitoring your screen, and do not try to open any other link except this Kubernetes.io. That proctor can cancel the exam if he's finding out you're going somewhere and you're copy paste from some another document. Do not use any document. Even don't use notepad, they are allowing you to open kubernetes.io. You can copy paste content from kubernetes.io to their terminal. It is very good examination, and if you are achieving certificate, that will be very helpful. So this was all about examination. Yeah.
So we are supposed to have a knowledge on the Linux, or if
Basics you should know basics of Linux administration, because we will be containerizing our application, and containerization and virtualization is a bit similar. Okay, in like we will be using Linux command in our container itself. Okay, let's say you want to create users in your container and you want to install something, so basic of Linux you should know, not much deeper but basics. Yeah. So okay guys, let me start. Why we need Docker first of all. So we will be talking about some legacy thing here first of all. So see, assume that you are a developer. What all things are required you to write or to create a web application? Okay, obviously we need to have first of all one computer, local computer. Like we should have one laptop. In our laptop we will be having one operating system. It can be anything. Operating system can be your Ubuntu, your RHEL, your Fedora, anything. On top of our operating system we will be installing our PHP compiler. If you are writing application PHP, so PHP compiler is required. If you are writing Java based application, then you need to have Java installed on your system. And then if it is a web application, you should have Tomcat. We are writing application in PHP, so we need to have Apache. Okay, these are the software that is required to create a web application. So what we will be doing, we will be creating our HTML, our all the code, binary, library, configuration, everything will be writing there. And once we are done with our work, developer is done with his work, so what we will be doing is developer will be pushing the code into centralized repository, whether it is SVN or Git, whatever it is. He will be pushing code there, and he will be informing to ops guys saying that, bro, just do the deployment. And he will be writing some mail. He will be creating tickets in his company saying that a new application is uploaded. It is pushed to Git, and you can deploy it in respective environment, whether it is whatever it is, like prod, UAT, and QA. So ops guy will be pulling the code and he will be deploying code in his environment. Okay, so assume that this ops guy just deployed that code in his environment. Now this ops guy started seeing some bugs, some issues there. Okay, what this guy will be doing, again he will be calling to his colleague, his developer, saying that, bro, your code is not working. He will be dropping him mail, he might be pinging him on Skype, or he might be WhatsApp him, he calling him, like they will be discussing what is the issue with your code. Your code is not working in my environment. Developer will be saying that I already tested that code in my environment, it was working fine, I don't know. Then they will be spending more time to troubleshoot it, and finally they are getting to know what was the issue. The issue was this developer developed that code by using latest version of PHP on his computer, and then he pushed it to Git. Okay, centralized code repository, and the code, this ops guy pulled that code and he deployed there, and he's seeing bug. What they get to know is developer wrote that code by using PHP's latest version, and in our environment, these guys are having PHP version 6.0. This was the problem that finally they find it out, because of latest version code is not supported by older version of PHP that is available in their environment. So here, this ops guy cannot update the version of PHP in his environment. Why? Because there might be lot of application already running on that particular version. If he is updating that latest version, PHP 7.0 to his environment, so it will be affecting to another application as well. There is a chance that a lot of feature, or some of the functionality might be deprecated in 7.0 in latest version. So he can't do that. So they will be discussing again, this ops guy and developer, okay, what you did, why you did. They will be dropping mail to their management, their manager, like again developer will have to write the code. First of all, developer will have to downgrade his PHP version on his computer, and then he will have to write code accordingly to 6.0, PHP version 6.0. Don't know how much time developer will have to spend again. Like it can be few minutes, it can be some days or some weeks. It depends on the code, what kind of code he is writing. Okay, so it depends. It is time consuming process. This is the thing we used to face in legacy deployment, and this developer people legacy thing we used to face. Now how Docker is solving this problem for us? You want to deploy your application in your environment. If your environment is having Docker in Docker, so what we should do? Developer will be containerizing his application. Okay, once your application is containerized, then we will be deploying containers in our environment. In our environment, we no need to have all things. We no need to have PHP compiler, and no need to install PHP compiler, no need to install separately Apache on our environment. Nothing. Only just what we need to do is we need to install Docker engine in our environment. Okay, developer will be containerizing that application. He will be pushing that application to its image repository. It can be hub.docker.com, or it can be JFrog Artifactory, it can be GitHub, anything. Okay, any kind of repository these people can use. Once your image is pushed to your repository, ops guy will be just here. The ops guy will be pulling that image from centralized repository, and he will be deploying to the environment where we will be having only Docker engine installed. So this is a plug and play kind of thing. You can take that image to any other environment as well. That will work. Here we will not be seeing any problem like previously we faced that this developer used latest version of PHP code and our environment is having different. We will not be having any PHP. We don't need to install any PHP compiler in our environment, just only install Docker. So what all Docker will be containing? Let's see. Previously we seen that PHP compiler, Apache, these all things we install on our environment, and then we are just copying code. We was just playing with code, like we are getting code from repository Git, and we are getting code from GitHub, and we are deploying like manually, legacy thing. But in container, what we will be doing is, in container we will be having our own operating system, our compiler, web server, and all the code. We will be wrapping all those things together, and then we will be creating containers in our environment. Okay, till here is it clear to you guys? If you are having any question, queries, please ask me. What Docker exactly is, just be seen. Yeah guys, all of you okay with it? All of you got
Anish,
all of you? Yeah,
he will convert that container into image and he'll send, or he will just send the container itself.
container as image. We will be, see, container will be created. How container will be created? Container will be created by using images. First of all, we will be containerizing our application. We will be writing all the code, right? Or we will be having base image inside the container. We will be having our compiler, web server, and our application. We will be wrapping all those things together. Means we will be creating one image, and by using that image, we will be creating containers. Without image, containerization is not possible. Correct?
Yes, Anish, thanks.
Yeah. So now we will be seeing, Docker architecture. Basic Docker architecture. We will be having Docker client, Docker server, Docker daemon. Basically, it is host is Docker server basically. So whenever both the components will be installed on the same server, same installation will be doing it. You no need to install separate thing. It will be installed at once only. Okay, during Docker installation, Docker client will be receiving the commands like you want to create a container. So Docker run hyphen detachable mode hyphen name, and name of my images somehow nginx, or somehow my application version regist. So this command will be received by Docker client, and this command will be sent to Docker daemon to process it. What Docker daemon will be doing is the same question I think Naveen asked previously. So see here, Docker daemon will be checking it out if that image is locally available, required image is locally available in server, so it will be creating the container by using that particular image. If that required image is not available in local server, it will be going to registry. Okay, it will be going to hub.docker.com and it will be pulling that image first of all to local server, and then it will be creating container. Okay, so this is architecture of Docker, and let me compare, virtualization versus containerization. We'll be comparing containerization and virtualization, how both the things are different. I'm sharing my screen for a second, for a minute. I need to get that PPT. Where is that PPT? Think, yeah, this is the one. I got it. So just now we seen what Docker is. Now we will be comparing virtualization versus containerization. Let me take you one slide here. This is the slide, I guess. Virtualization. So guys, whenever we are talking about virtualization, what virtualization exactly is? What is your understanding? Any clue about that? Yeah, guys.
It virtualizes that hardware components so that we can
Yeah,
create virtual machines.
virtual machines, right? Okay. Anybody else wants to say anything?
Each
Nobody
VM
wants to say?
has its each VM has its own operating system,
Correct.
and also there is a chance of resource wastage when compared with containers.
Correct. Okay. So let's see, whenever we want to create a virtual machine, so what kind of virtualization we'll be using? Basically, we are having two type of virtualization, type 1 virtualization and type 2 virtualization. Whenever this is the example of type 2 virtualization, type 2 virtualization will be having, it will be installed on host operating system. In my system, can you see that I'm having Windows 10? On top of Windows 10, I installed Oracle Virtualbox. This is type 2 virtualization. Oracle Virtualbox, this is my hypervisor. Can you see hypervisor? We can have different hypervisor. I'm using Oracle Virtualbox. You can go with VMware Player also. Okay, some another one is also available in market, but Oracle VirtualBox is the best one. Always go with Oracle VirtualBox. On top of, by using this hypervisor, right? What I'll do is I will be creating virtual machines. Each virtual machine will be having its own dedicated resource in it. I will be having my own operating system in it. On top of operating system, I can install my compiler and libraries on all, and then I can host my application. Okay, same thing I can do here. So whenever we are talking about virtualization, means we are talking about hardware level virtualization. We are virtualizing our hardware. How we are virtualizing hardware? Let's see. Example, practically. Click on new button to create a new virtual machine. I'm just writing here Red Hat S123. This is the name of my VM, just I'm giving it here. Click on next. Here I'm assigning some amount of RAM to it. This one, right? RAM I'm assigning. So see here, once RAM assignment is done, then it is telling create virtual hard disk. Now I can create virtual hard drive. I will be going with default VDI, dynamically located, and here I need to define my virtual hard drive size, from where these virtual machine will be getting, this RAM or this hard drive. Obviously, those resources like your RAM and your CPU and your hard drive, these things will be accessed from your host machine. Okay, here we are virtualizing our hardware. So once our VM is ready, so whenever you will be starting this VM and you will try to install any operating system in it, so those resources will be available for dedicatedly available for your server or your operating system. Whenever you are installing Linux operating system, so your setup will be thinking, your installation setup will be thinking that okay, this is a separate machine where resources are dedicatedly available for me. This is hardware level virtualization. Okay, now let's say for an example, uh, you are assigning some amount of RAM to each of this virtual machine. Let's take example of 1 GB RAM. We are assigning 1 GB RAM, 1 GB to each of this virtual machine. F1 is having 1 GB, F2 is having 1 GB, F3 is having 1 GB. App1 is using 950 MB of the RAM. It needs more RAM even now. App2 is using 100 MB of the RAM. Rest of the more than 900 MB is free. App3 is using 200 MB of the RAM. More than 800 MB of the RAM is free. App1 need more RAM. At the time, we can have some scenario, we can have some problems like my VM started running slow and it is stuck in somewhere, my application is not accessible. We need to increase the RAM at that time, right, to fix this issue. Can app2 and app3, this app1 can ask this app1 can app1 ask app2 and app3 to share your RAM, share your memory? Can app2 and app3 will be allowing app1 to share its memory? Is it the scenario, is it possible thing while your all the VMs is up and running? Yeah guys, even F1 can ask for host machine to give me more memory. Yeah,
No.
no,
No,
right?
that is not possible.
Yeah, it is not possible because your VM is up and running. You cannot make changes in your VM's configuration while that VM is up and running. If you want to increase memory to app1, if you want to decrease memory to app2, okay, you need to shut down these VMs. You need to take down this VM, then only you can reassign its memory. You can see here, go to Oracle Virtualbox, see it is running. How we can change? Click on settings. Setting window will be here. Can you see that it is disabled? We cannot change memory here. Even we cannot add new hard drive here. It is disabled totally. If you are thinking to increase CPU here, you can't do that. You can't increase CPUs here. Okay, this is the thing. Yeah, so we need to take down the VM, then only we can increase or decrease resources here. Okay, this is hardware level virtualization that we seen here. And now let's talk about containerization. What happens in containerization? What we need to do to create containers? We will be having our own operating system. We can have our virtual machine as well. We will be installing Docker engine or container engine. Basically here Docker engine is not written, here container engine is written. We will be installing container engine in our system. By using container engine, we will be creating containers. Basically in market, a Docker is a very powerful and competitive container engine as compared to other. We are having a Rocket container engine, we are having Wordlet, we are having Kata, we are having Core OS, we are having LXC, LXT. So even Podman came in market. Podman is a containerization tool that is product of Red Hat. There are so many actually. So Docker is the best one. That is the reason we are using Docker. Everywhere people are preferring to go with Docker. So what we will be doing here is, once we are using containers, so in containerization we no need to even assign RAM. We no need to assign hard drive to your container. We no need to assign any CPU to your container. So how containers are getting created? Container engine will be creating your container, and what all things your container will be containing. Your container might be having a small your operating system in it, and on top of that operating system your application might be installed there. You can install your application in that container. So how that container is running without RAM and all? Basically containerization is nothing but operating system level virtualization. Okay, operating system level virtualization. If my container need 1 GB of the RAM, my container will be asking to host machine. It will be utilizing host machine's RAM, 1 GB RAM. If my container need CPUs, it will be accessed from a host machine. Again, when it comes to storage, it will be storing this data on host machine itself. Okay, so how it come possible? What all tools internally Docker is helping to create? Docker is allowing to get required resources from host machine. Let's see. This is the Docker internals that is allowing us to make it possible, create container, assign required resource from host machine. For storage, we are having device mapper, BTRFS, and AUFS. To store your data, your containers data in your host machine, Docker engine uses overlay drivers. Okay, overlay storage driver, basically overlay to fs. This is the latest one. This is the old one, whatever we are seeing on the slide. These old storage techniques. Latest one is overlay 2. So Docker uses overlay 2 to store your containers data on your host machine. Namespaces, basically namespace will be managing your processes running inside the container. As I told you, it is operating system level virtualization. So it will be getting resources from host machine. Containers are nothing but a kind of processes. Okay, containers are process. Whatever processes are running inside your container, you can access those processes from host machine. We can access running container. We can access containers process from host machine. We can see what process is running inside this container without logging in that container. Okay, now when it comes to process, can we install multiple nginx on the server, on our virtual machine, on our remote server? Okay, can we do that? Whether it is nginx or apache, it is not it is the same thing, similar thing, actually not exact same but similar. Web server, we cannot install two server in the same machine, or we can do that. Any clue on that, guys? Yep.
Yes, we can do that, but the code has to be different. Yes.
Okay, we can do that, but this is not the standard way to install multiple Apache servers in your environment. That's not a good idea. If you try to do that, first of all, how you'll be doing that? apt install Apache 2, right? This is the command to install Apache. Once you're pressing enter key, if Apache is not installed, it will be installing it. Correct? That Apache will be installed on your system. That package will be installed. Next time, whenever you will try to do install Apache again, whenever we are trying to install Apache on the same system, you need to execute same command, apache apt install Apache 2. It will throw message to the screen saying that latest version of Apache is already installed. You can't do that. To do that, you need to get your Apache binary from internet, download that package in zip format, and then make some configuration changes and start that Apache. It will be started after fixing some of the configuration, right? You can do that, but it is not a good idea, right? Now in containerization, what happens is, in our environment where we will be having let me show you one slide. In this environment where our Docker engine is installed, we can start multiple Apache containers or multiple nginx containers, right? As I told you, right, you cannot install multiple Apache. So, and if you are trying to do that, you need to make some configuration changes. Again, I told you one term, right? Here, whatever processes are running inside the container, that we can access from host machine, right? At that time, namespace comes into the picture. That will be helping you. Your each processes will be wrapped, okay, so that they cannot conflict, they cannot talk to each other even. Okay, once you are starting one Apache container and second Apache container, third Apache container, fourth Apache container, so all those processes will be wrapped in namespace. They cannot even communicate. It will not be conflicting it because of isolation. Each process will be isolated. Okay, and each process will be thinking the resources are dedicatedly available for that particular process only. This is how Docker engine is helping us to create multiple containers. First thing, to enable networking to reach or to access your application that is in containerized environment, some networking feature is there available in our Docker internals, and that will be allowing you to communicate with our container, or container to container communication. We can enable it. Bridge is a kind of networking in our containerized environment that will be helping us to do that. Virtual Ethernet, we will be learning. IP tables will be, it will just to make firewall rules. Now C group is a component that called C group. What is the use of C group? As I told you, whenever our container need required resources like RAM, like CPU, right? So those resources will be provided by C group to our container. 1 GB RAM I need, C group will be providing me. I need more CPU, C group will be helping me to get resources. To make it secure your container, we are having SELinux, SAPComp, and iParma. Okay, so this is some rules that will be making our container secure internally. We need not do anything. So this was the theoretical part about Docker containers. I think you might be thinking that I'm saying only theory part. So, but it is required. Without without knowing, like, basics and theory part, we can't do anything. We can't learn what Docker exactly is. Let's compare your virtual machine and Dockers. How it is accessing our memory and Docker, how Docker is accessing memory from host machine, whether it is blocking some space like memory like virtual machines or not. Let's see. In case of virtual machines, we have take example of these 3 VMs. We are having 3 virtual machines where first VM I assigned 6 GB of the RAM, second VM I assigned 4 GB, and third VM again I assigned 6 GB of the RAM. Okay, now here we can see first VM is using 4 GB of the RAM, 6 GB is unnecessarily it is blocked, 2 GB is unnecessarily blocked here. Okay, it is freely available there. Same with second virtual machine, 3 GB is utilized here, 1 GB memory is unnecessarily there. Same with third VM, 2 GB it is utilizing and 4 GB is unnecessarily blocked on my system. Now in case of containerization, whatever memory is required to execute your container, only that much memory will be accessed from your host machine. Getting it, guys? Only that much memory will be accessed from host machine. Like here in case of Docker container, we can see 4 GB required to run app1 container. So 4 GB will be accessed. And even as soon as it is reaching 4 GB to 1 GB or 2 GB, so that much RAM will be, it will be releasing it for host machine usage. It will not be blocking anything. Only required resources, only required memory will be accessed from the host machine. That's it. Getting it, guys? This was the comparison of virtual machine and Docker containers.
Is there
One
any
more
reservation that one? Will it be going more than 4 GB also if it is required?
If your container need more RAM, so it can access whatever RAM is available on your host machine. Let's say your host machine is having 16 GB of RAM. If this container is continuously accessing 4 GB, and it is, as soon as it is required more RAM, 10 GB, 12 GB, 13 and 14 and 16, finally maximum memory this container can access is whatever we are having on our host machine. Similar, it can access it. If you are thinking that my container is resource hungry, you can limit this RAM. You can put some hard limit on the container so that this container can use only this much of the RAM, not more than that. If it is trying to do that, at that point your container will be killed with error out of memory, OOM error, OOM killed.
Got it.
Any question, guys, regarding that previous slide? Yeah, guys. So let's see here major comparison. If we are talking about virtual machines, so it is very heavy in size. Basically, we need to have at least, if you are planning to install Ubuntu minimal version, you need to have 4 GB of the hard drive space. It needs more RAM. You need to locate some of the RAM to it, and size wise. Okay. And Docker container as compared to your virtual machine. Let's take an example of Ubuntu. As I told you, 4 GB minimum hard drive space we need. We need to allocate 4 GB to your virtual machine. Containers, Docker container is very lightweight. I think your Ubuntu image here in Docker containers, it will be in size 150 MB or max to max within 200 MB it will be. Okay. Startup, how your VM will be starting up, it will be slowly performing post power on self test. If everything is okay, then it will be going to MBR. It will be going to then it will be going to grub will be executing kernel will be manually. All those booting process will be followed by your virtual machine. It will be taking some time, and slowly your VM will be started. Here in Docker container, as soon as you are pressing enter key, your container will be up and running immediately. Okay. Integration part, when it comes to integration part, it is hard. Like if you want to use scalability, you want to use it on something CI/CD thing, so it is very hard at the time in case of virtual machine. But if you want to do the same thing in containerized environment, it is quite easy and quite simple. You can scale environment, you can scale up your container, you can scale down the container by using some tools. Okay, so this was the comparison in between Docker, containerization, and your virtual machines. I hope you guys are very clear on this concept, virtualization versus containerization. If you are having any question, queries, so ask me. I will reply. Yeah, guys. Till here, everything is clear.
Yeah, it's clear.
Okay. So now we will be seeing overview of Kubernetes. Why Kubernetes is required? Why Kubernetes is required? Let's say we created our containerized environment. Okay, we are having this one virtual machine. In this virtual machine, we installed a Docker engine. We installed Docker engine. Our Docker engine is installed here. Now I can create multiple containers here. Okay, I can create multiple application container here. That is working fine, and those applications are working fine. That's good. Now when it comes to highly availability, okay, when it comes to highly availability, I cannot achieve highly availability by using this single Docker server. I can create multiple container of same application here, and then I can do load balancing in them. But manual intervention is required to do that, right? I can to install Nginx, and then I can do load balancing in between multiple container. I can do that. That's fine. If one container is down, second container will be serving that. But what if this machine itself it is down? Then what we will be doing? We can't achieve highly availability by using the single machine. To achieve highly availability, we should have multiple nodes, right? We should have multiple server we should have to achieve highly availability. Correct, guys? We will be creating our cluster where we'll be having multiple virtual machines. Okay, so how we can how we can manage our container at the time by using Kubernetes. Okay, by using Kubernetes we can create one Kubernetes cluster. In the Kubernetes cluster we will be having one common thing installed called Docker engine. Docker engine will be installed in all the nodes. Okay, we will be having one master node in Kubernetes. Okay, master node will be managing its worker node 1 and worker node 2. Basically we will not be doing any deployment. By default all the deployment will be done only on worker nodes. Deployments will not be getting created on master node because master node needs master node will be having its own services and component installed in it. Those component will be managing your worker node. If you are doing deployment in master node, your deployment needs resources. If resources are not available to manage your worker nodes, then what master node can do? You will be facing issues. So that is the reason we will not be having any deployment in master node. Getting it, guys? Now in this master node we will be having some of the component. Okay, some of the component install in it that will be managing your worker node. Once you are creating your deployment, so your deployment will be getting created here, your containers will be getting created here. So we are having one term called pod in Kubernetes, one term called pod. What pod will be containing? Let me create pod is nothing but a container of containers. We will be creating Docker containers inside the pod. It is quite easy. It is not a big deal. It is a simple thing. Okay, we'll be creating multiple container in a pod. We can create multiple container in a pod. If you want to share any data between these two containers, we can create here, empty directory volume. So that will be helping us to share data in between containers volume. Okay, this is my container one. Let me decrease the font size here. 10. It looks good. Container one. Here we can have container two. So they can share data by using empty directory volume. Okay, like this. So we can create containers, pods. Sorry, this is one of my pod. Here I can create pod here. Okay, pod. Pod. If I want to create a replica of my pod, I want to spread a replica of my application in my cluster. So I will be using some. Give me a second. Yeah, if I want to create a replica of my pod in my cluster, we can use deployment, we can use replication controller, replica set. Once we are, slowly we are learning what replication controller is, what replica set is, then we will be learning. We can see differences between all these things: replicas, replication controller, replica set, and deployment. These are the important things. Now, how we will be accessing this application outside of the cluster? To do that, we will be creating one service. Okay, we will be creating one service. We will be creating service here. We'll be creating service. How this service will be getting to know I need to make it accessible, this pod or that pod, and we can have multiple pods, right? How a service will be getting to know? Basically, services will be searching for defined label. Selector label will be having wherever app colon my app is defined. Just okay, my app. Wherever app colon my app label is defined in the pod, just map only those pods. This is how service will be mapping these pods. And as I told you, we are having a different kind of service. If you want to make it accessible within the cluster, then its type should be cluster IP. If you want to make it accessible outside of the cluster, then it should be node port or load balancer. Node port. It could be node port. Now, people from outside of the cluster, if they want to access your application here, so they will be hitting to service, and service will be allowing you to access your pod, your application. Basically randomly it will be just doing load balancing internally in multiple pods and will allow you to access. How you can access it. Okay, containers is nothing but, if you are talking about only containerization, so we are doing port mapping, and during by using port mapping we can make it accessible our application outside of the cluster. Okay, let's see what all components we are having in the Kubernetes. Let me tell you. I'm sharing my screen again for a while. Where is this one? DevOps, Kubernetes, document. So guys, I'm just giving you, I will not be taking much time. Yep, I think my screen is visible to you, right? It should be visible to you. So in our master node, we will be having some of the component called controller manager, API server, scheduler, and etcd. Etcd will be storing your cluster state, like how many worker nodes you are having, what all deployment is done on those nodes. Everything will be available into etcd, complete cluster state, like node 1 is having this deployment, this many of the replica. Okay, so controller manager will be this is API server, and API server is a communication gateway. API server will be checking it out. It will be authenticating the user. If your user is authenticated, it is having permission to create deployment. So it will be storing whatever deployment you want to create. It will be storing its information in etcd. Then it will be informing to scheduler. Scheduler again going to your node in round robin method, saying it will be following round robin method. One by one, it will be going to your worker node to check it out in which node required resources are available. Once required resources are available in this node, so it will be informing to kubelet to create a pod here. So your pod will be getting created. If you define like 3 replicas should be created on of this application on my node, so one by one your scheduler will be checking the node. Wherever it is finding it out resources are available, it will be informing to kubelet create the pod. So each node will be having one of the replica of your pod. Okay, so kubelet will be reading information from etcd. Again, kubelet will be reading information from etcd. So what all pods to be created with what configurations. Okay, this is how your Kubernetes architecture it is. This is how your deployment will be getting created on the cluster. This was just a small overview. Once we are continuing the session, I will be describing things in very detail. Controller manager is having a lot of controller managers in it, subcontroller managers in it, node controller manager, replication controller manager, stateful controller manager, so many. So we will be learning all of them once we are continuing the session. I think guys, this is enough for the demo. If you guys are having any question, queries, so please ask me now regarding this demo.
Anish, will you be covering for any upgrades and backup also?
So I think it should be available in my node. If it is not there, and if you are having enough time, then I can tell you how to take. I'm sorry. Okay,
I have not seen
somebody
anything
discuss.
in this
No, no,
document
no.
actually.
Yeah, okay. It is not there. Backup. How we can take complete clusters backup and how can restore it. It is not
I
there.
have not seen.
Okay, no
Not
worries.
seen.
No worries. Yeah, no worries. I'll tell you. I can tell you that this is something important that I can cover it. If you are having enough time, definitely I'll covering this thing.
And about
But
upgrades,
upgrades, I think upgrades should be in it, right? Upgrading should
upgrades
be
and
here.
rollback.
Yeah, rollback will be there, right? Rollback we can see. The deployment that will be done on deployment section. You're asking for application upgrade. If we are having rolling
Yes.
upgrade somewhere. Rolling upgrade is their replication controller deployment, and that will be covered on this one deployment. Can you see that? Rollout,
Okay.
rollback, rollout history,
Okay.
recreate, this strategies, deployment
Okay.
strategy.
Okay. Got it.
It will be there, right? Without this, Kubernetes is incomplete, right? This is the use
Okay.
that people are preferring Kubernetes.
Yeah. Got it.
Yeah.
And will you be sharing in, some real-time scenarios, like what type of issues we can expect in the environment or something,
Correct.
Anish?
So what we will be seeing here is this course content. This course content is specially created for corporate people who is working in company, and what scenario they can face. Just if you are going through this course content, then definitely you will be finding it out. Yeah, this kind of thing can be there. How to create deployment. Your manager can tell you. He will be telling you create the deployment with this requirement. Okay, where you need to use config map, where you need to use secrets. So we can combine all those things together, and then we can do it. It is very simple. Like I can introduce with you like grocery and vegetables in a kitchen. What you want to prepare, it's up to you. But we need to know the basic things. Yeah. Yeah, guys. Anybody else?
And will you be sharing like any
Yeah, Anish,
documents
I
or
have a
recorded
question.
sessions for the reference?
Yeah, definitely. You will be. I will be sharing documents with you, and my team will be sharing recordings because I don't have access of recording. My team definitely will be sharing with you. Because in
And in
future
your
reference, if you are revising that course, if you want to you forgot something, you want to see some content, so you can see that recording.
okay. Is there any backup classes conducted if we miss in case? I think.
Backup classes, like record. You will be having recordings.
Okay.
You will be having recording, and even if you are having if you are having any confusion, any doubt, after completion of that next session, you can ask me.
Okay.
Okay.
And in your scenarios, you are going to use Ubuntu OS for the node on the node?
Yeah, correct. Ubuntu we will be using.
Okay.
I will guide you how to install operating system, how to install, how to assign IP addresses to your virtual machines. All those things will be covered. How to enable communication in between all the machine, and how we can access that virtual machine or host machine. Everything will be covered.
We have to be ready with laptop with Oracle Virtualbox.
Virtualbox,
That's it, right?
Oracle
Okay.
Virtualbox, and Ubuntu image. If you're downloading
Okay.
Ubuntu image, always download LTS version. Don't go with this non-LTS. Ubuntu, ubuntu.com. Go here, accept all. Click on download. Ubuntu server. Go with Ubuntu server. Option number 2. Here it will tell you download Ubuntu server 20.0.4.3 LTS. LTS is nothing but long-term support. If you are
Okay.
going with non-LTS, that can be discontinued anytime.
Okay. Got it.
Yeah, guys. So I'm done with today's
Yeah, Anish, I have a
demo
question.
session.
Which component
Yeah,
of
Harish.
master is responsible for checking node health and also like uh, node health and also resources on nodes?
Yeah, so basically, we will be covering all those parts once we are continuing the session. So these things will be covered: node health, kubelet is
Mm.
there that will be
Is it
continuously in touch with. Yeah.
okay? Is it the responsibility of scheduler or API server?
Okay. So that's the reason I told you right here. We will be having controller managers. That slide I closed it actually. We will be having controller manager. If any one of your node is down, so in controller manager we are having one node controller. I'm really sorry, guys. I'm really sorry.
Mm.
Somebody is ringing badly. I don't know. My brother is just there to see. Give me a second.
Sure.
Yeah. So what I was saying you is we will be having controller manager. In that controller manager, we will be having node controller manager that will be monitoring your nodes. Okay, whether all those nodes are up or not. If any node is going down, so remediate the situation. To try to commit back the situation, come back that node. If that node is anyhow it is not coming back on the system, so it will be evicting your deployment, your pods from that particular node to whatever node is up and running. It will be moving deployment like that.
Okay. And master node will also share the workload, right? Along with the workers.
Workload means which workload it will be
Like
sharing,
pod
master node.
scheduling. I mean, we can deploy pods on master also along with the workers, right?
Okay, good question. I told you
Mm-hmm.
just few minutes before, like your
Mm-hmm.
deployment will not be created on master node. Why? Because see, let's see this thing. Your node, master node is already having something to do, manage your its worker node. If it is
Yeah.
2 3 node, that is fine. If we are having more node, so master node will have to in touch with them daily, right?
Yeah.
It will sorry, it will have to manage whatever worker node is. It will be just managing them, right? What all components are running, what if anything goes wrong, if one node is down, what to do, right? So what will happen here is like master node. If we are doing deployment in master node, if master node started facing some difficulty with the resources, like RAM is not available, and CPU is not enough CPU available for itself to for your deployment, and all deployment, they mm, management component and your deployment, they started conflicting now because of the lack of resources. So
Mm-hmm.
what will happen is you will not be able to manage your cluster properly. This is not a good idea. By default, deployment in master node is disabled. First thing, you can enable it by using 10/10 toleration. because of taint intoleration, that deployment is disabled on master node. If you are thinking to do the deployment on master node, just change its taint. That's it.
Oh.
Okay.
And for this, like managed Kubernetes services like EKS, AKS, and GKE will have no master, right? Only will have worker nodes.
Yeah. We will not
These
be
are managed.
discussing about AKS and EKS, but yeah, definitely if you are having question regarding AKS and EKS, so we will not be having any master node in our EKS or AKS cluster. That will be managed by your cloud provider. Okay,
Yeah.
they will be taking care of this thing.
Mm.
If even we are
Actually, we are
having,
using EKS
each
clusters. Yeah, we are using EKS clusters. If you cover some portion of EKS, also it will be like helpful for us.
so I will try, not promising it, but because the thing is that we are already having very lengthy course content, lot of things we'll have to cover here. Whenever it comes to out of the course content, I'll try to do that.
No,
But if we are having time, so I will be clearing doubts at the time.
no.
Okay, guys. Yeah.
Thank you.
Okay, guys.
So
This,
Anybody want to ask?
any,
Yeah.
and this I need how we can test the worker nodes one in pods, whether it is the worker node 2 fail and worker node 1 is shifting or not. How we can test that procedure also?
Okay. If your worker node, I'm sorry, if your worker node is failed, it is not working, right? Your worker node is
Hmm.
failed. So as I told you just now, I told you just few seconds before, like we will be having node controller manager that will be taking care of this thing.
Okay.
Yeah.
And one more thing, yeah, for
Mhm.
how many pods in the container we has to get for volume? For is there any for each pod there is one volume, or for 5 pods one volume? We has to define, or it has to be taken care master node.
Okay, this is the good question, but the thing is that I'm sorry, guys. Okay, so here what we will be doing is we no need to create volumes first of all. Okay, this was just example I told you. We no need to create volume. That whenever in whichever node this pod is getting created, it will be taken care by that kubelet. Okay, if you are thinking that I want to share some data in between these two containers, I want to share some of the data from container 1 to container 2. At that time, we will be creating volumes. See here, I created that volume like this. We will be creating volume. But we no need to create separate volumes for each the container. It is not required at all. Only on if it is required, then only we'll be creating it.
Okay.
Yeah.
And the worker node IPs and worker and master node IPs are different. How it has to function one-to-one interaction for we has to verify with any logs like that.
No, repeat the question.
We have master node. In that master node, the functioning will taken by worker nodes. We can deploy in worker nodes. In the worker
Okay.
nodes, the master node IPs will be different. IPs will be different. How we can manage with that IPs is functioning one-to-one. We can how any failures from master node to worker node, that IPs is not pinning, like another worker node failure, and coming back that worker node is getting IP fail. Like that, we can mutually coordinate from master node to worker node IPs interaction.
No. So first of all, whenever we are creating cluster, right? This is how we are creating cluster. Once this worker node is joining the cluster by using kubeadm join command. Okay, guys, give me a second. Some getting continuous. Yeah, guys. So what I was telling you, whenever this worker node is joining this master node, so it will be already having, if in situation if it is joined the cluster and went down somehow, it went down this worker node with its different IP address. Once this worker node is coming back, automatically it will be joining the node. We no need to do anything because of kubelet. Okay, kubelet will be there. It will be informing to node manager, controller manager. So it will be there. Once it is back, it will be automatically joining it.
Any new releases function update, it will be happen. How we can verify in the worker nodes or master node? We can see
Okay,
that
you want
also.
to, yeah, you can see that also. If you are updating Kubernetes version in any of the worker node, okay, any of the worker node, let's say this worker node is having one different version of Kubernetes installed. How we can check it out? Nothing to do, simply execute kubectl get node command. At that time it will be telling you this node is having this version installed in it.
Comments will share
Yeah, guys.
for Docker as well as Kubernetes in the after class session completes.
Yeah, which one to share?
Document after session completion, any document related to
correct. I will be sharing whatever.
we can forward, no?
Yeah, no worries. I will be sharing documents and even command history and PPT. Those things will be shared after completion of the session. End of the day, I will be sharing it.
We can go further. We can
Yeah,
go
yeah.
further again to repeat all the things. Again, we forward
Correct.
after a session. That's what.
Correct. So what I'll do is, end of the day, I will be sharing all the deployment YAML file, Docker command history, PDF. I'll share it. Don't bother for that. Okay, guys. So I'm done with the session. Let's connect tomorrow morning, same time, 8 a.m. And we will be learning Docker first of all, and we'll be moving slowly to our advanced topics. Okay, guys. Bye bye.